Welcome to Module 7, Lecture 7, Other Benefits of Silvopasture, from the web-based course, Pine Silvopasture in the Southeast. As mentioned throughout the course, a well-designed silvopasture system can have many added values. It can provide habitat for quail, turkey, and other wildlife due to a diversity of structure, shade, and forages. Pine straw can be periodically harvested if desired, to be utilized or sold for landscaping and mulch. A well-managed silvopasture enhances the aesthetics of a property and can actually increase property values. In addition, there are other tree species besides the southern pines that can be established, such as pecan or black walnut, to provide alternative crops. There are also other livestock choices suitable for silvopasture. If wildlife habitat enhancement is a goal for your property, you must be aware that different wildlife species have different habitat needs. Some may exist quite well in a silvopasture system that favors trees and livestock, while others will need special considerations. Species preference from the landowner's perspective will dictate the management decisions. Management can be intensive or passive. Periodic management practices, such as thinning and prescribed burning, naturally improve wildlife habitat. There are a multitude of forage choices that can favor wildlife. By overseeding cool season grasses and legumes, you can greatly increase food supplies, especially for deer and turkey. Livestock grazing management and stocking rates must also be appropriate for the forage to provide these wildlife benefits, if livestock are present. The producer must know the compatibility of the forage plant to soils, climate, moisture, grazing management, and pesticide applications. As previously covered in Module 6, native grasses enhance wildlife habitat. Therefore, if this is a goal, choose native grasses for livestock forage instead of exotics such as Bermuda grass or fescue. Native grasses provide excellent cover for game birds. Bunch grasses allow chicks mobility to feed, and they also can provide excellent quality livestock forage. So you shouldn't be losing anything production-wise by planting natives. Some drawbacks, however, are that they can be expensive, some can be slow to establish, and many require special equipment to plant or sprig. While we have focused primarily on one type of silvopasture system throughout this course, there are other livestock and tree species options that you may be interested in. Traditional silvopastures in the southeast primarily involve cattle. However, other livestock options include sheep, goats, horses, turkeys, chickens, emu, if you're brave, or even game animals such as bison and deer. Integrating meat goat production into silvopastures has gained popularity due to an increase in demand for goat meat by certain ethnic populations. Goats can also be introduced into weedy or unmanaged forests to clean out invasive species and undesirable plants such as brambles and vines. Many different tree species have also been integrated successfully into silvopasture. After the pines, pecan and black walnut are popular alternative silvopasture species choices. Rotations for timber are considerably longer with these species. If you're interested in securing additional retirement income for your grandkids, it can take 60 to 80 years to produce timber from black walnut, for example. However, some producers have managed it for nut production to serve as an additional annual crop along with their livestock. Due to the relatively short rotations of Christmas trees, as a tree crop anyway, some Christmas tree producers have integrated livestock like sheep into their plantations. Pine straw, especially from longleaf pine, is highly valued as a mulch. While more commonly managed in traditional pine plantations, straw can be harvested from a silvopasture. However, care must be taken not to over-harvest straw, which can reduce the nutrient cycling component in your pine stand. Another added value of silvopasture that we've mentioned is aesthetics. A well-managed silvopasture can increase property values through its aesthetic quality. Alleyways between the tree rows provide view sheds that many find much more attractive than plantation forests. Wildlife such as songbirds and deer can also be more readily observed due to lower stand densities. Some silvopasture producers have earned additional income leasing their land and silvopastures to hunters, who also take advantage of the view sheds and forage areas for deer and turkey hunting. In summary, native grasses and forbs incorporated into a silvopasture system can provide an increasingly rare cover type in the southeast and increase wildlife, which increases the aesthetic value of a property in silvopasture. Ultimately, the quality and diversity of benefits of a silvopasture is up to the landowner's management goals and decisions. Welcome to Module 6, Lecture 6B, Forage Management, from the web-based course, Pine Silvopasture in the Southeast. Establishing additional forage may be required to provide balanced nutrition for livestock in a silvopasture. Forage establishment in a silvopasture is not very different from accepted open pasture practices. Site preparation and seeding are generally the same. However, fertilizers and soil amendments must also account for the tree component. For pine silvopastures, forage species should be selected that can tolerate the low soil pH that the southern pines favor. As previously mentioned in Lecture 6A, forage systems that incorporate cool and warm season grasses can provide almost year-round nutrition for cattle. A general guide for warm season versus cool season grasses is to plant around an acre of warm season grasses for every 2.5 to 3 acres of cool season grasses. Generally, cool season grasses during their production seasons are higher in quality but lower in total biomass produced. Producers need to be familiar with the growth period of your forage, especially in a rotational grazing system. In general, cool season forages produce most of their growth in the spring, while warm season forage growth occurs between April and October. Forage growth is very dependent on the species. Some produce growth very quickly and taper off, while some begin growth later in the season and extend their production further into early fall. After forages have been grazed down, regrowth initiation takes place within 3 to 7 days. The last cutting or grazing of a forage or pasture should allow enough regrowth before a killing frost to allow plants to store enough carbohydrates for the following year. This is especially important for perennial forages. Low-growing forage like Bermuda grass and white clover can typically withstand late-season grazing due to carbohydrate reserves in their roots and stems. Continuous selective grazing weakens desirable forage species, creating weedy pastures in areas of overgrazing and undergrazing. This creates high-impact areas, shown in the photo here. These areas can have detrimental impacts on tree growth and survival. Producers must monitor grazing intensity of their livestock and make arrangements to move cattle into different paddocks if they are overgrazing certain areas or undergrazing others. A rotational grazing plan must be followed to ensure adequate forage recuperation and production to meet livestock nutritional needs. While there are various formulas to determine the number of grazing units or pasture areas to establish, most systems have 8 to 10 pastures, or paddocks, which provide ample rest periods for grazed paddocks. Rotational grazing is covered in more detail in the livestock management module. Care must be taken for herbicide applications for both tree seedling and forage components in a silvopasture. Newly planted tree seedlings are more susceptible to herbicide drift. Issues with weeds and other competition species should be more intensively managed during the site preparation phase of silvopasture establishment to minimize the need for intensive herbicide applications, especially near recently established seedlings or trees. Livestock should not be introduced into a silvopasture until the top branches of the trees have grown out of their reach. Until trees are established, the forage and alleyways between tree rosettes can be managed for hay production. In summary, Proper forage management is essential for a healthy and productive silvopasture. Following a rigorous rotational grazing schedule and monitoring forage regrowth will ensure that nutritional quality of forage is sustainable for livestock. In the photo shown here, you can see that the left part of the pine stand is unfertilized, it's been unplanted with forage, and is covered with pine straw. The right side of the photo is planted with fertilized ryegrass. Welcome to Module 6, Lecture 6A, Forage Selection, from the web-based course Pine Silvopasture in the Southeast. There is no all-season plan available that can serve effectively as a year-round forage. Producers must recognize the limitations and benefits of a plant's seasonality. Therefore, incorporating both cool and warm season grasses is essential to extend your grazing season. Incorporating native, non-invasive forage species is also recommended, as these species tend to be naturally robust, provide nutritional diversity to livestock, and provide benefits to wildlife species as well. Forage choice should take into consideration plants that are compatible with the site, including soil type, temperature, and precipitation, that can handle drought and are productive under partial shade, and species that are responsive to intensive management and tolerant of heavy utilization of a rotational grazing system. Looking at geography and site considerations, the more northward you go, cool season grasses would be more desirable, while warm season forages make up a larger portion of a grazing system in the south. With new forage establishment, it may be necessary to implement herbicide management or prescribed burning to allow desirable forage species to establish or re-establish. Forages also have soil moisture and pH preferences that need to be taken into consideration. The following slides show a range of common forage grasses, both native and introduced, and provide general information on each. Bahia grass has an optimal production range from February through October. It tolerates a wide range of soil types. It's good for brood cow maintenance and produces fair hay. In addition, it also has good drought tolerance. In fact, it is an indicator plant for dry and droughty soil conditions. Bahia grass is easily identified throughout the southeast by its distinctive Y-shaped seed head. Hybrid Bermuda grass has an optimal production range from March through mid-August. It's also versatile and drought tolerant. It contains more dry matter than other forages when cut for hay, around 25 to 30%. There are a number of varieties of hybrid Bermuda grasses, and they have become preferred forage grasses because they tolerate overgrazing better and produce more grazing and hay per acre at a lower cost than many forages. Eastern gamma grass is a perennial that has an optimal production from March through mid-July. It's actually a native species that has been rediscovered lately. It requires moist, fertile sites and a 6-week chilling process before it's planted, but you can order pre-chilled seed to get beyond that chilling process on your own. Eastern gamma grass is highly productive in a rotational grazing system. If well managed, gamma grass can produce up to 4 pounds per day of weight gain on steers, as it has a protein content that rivals alfalfa. It prefers full sun, so it would be a species desirable in more open areas of a silvopasture. It has also been found to be beneficial for wildlife habitat. It is a deep-rooted grass that is also drought tolerant and can achieve regrowth of up to 2 inches in a day. Eastern gamma grass's adaptability to waterlogged soils also makes it an excellent choice stream bank buffer. There are several clovers that can be integrated into your silvopasture forage system. White clover is one, however it requires a higher pH at 6 or above, but white clover increases forage quality throughout the pasture. It fixes nitrogen and has an optimal production from October through mid-November. Subclover needs fertile sites, but it's shade tolerant and has an optimal production from September through October. Crimson clover is an excellent winter forage to mix with other grasses. It also makes a good hay or cover crop. Wheat, barley, oats, and rye are common small grain forages typically used as a supplement for growing cattle. An acre of small grain pasture can carry approximately 500 pounds of live weight per acre. Weaned calves can receive all needed protein and energy from good small grain pastures. Wheat, oats, and rye are good winter forages and cover crops as well. It is important to note that the nutritional value of small grain forage declines rapidly with increasing maturity, so make sure you optimize the grazing period and know the life cycle of your forages. At the bloom stage, wheat yields are often 50% higher than at the boot stage, with little loss in quality. Barley is generally more susceptible to winter kill than wheat, especially when it has been overgrazed. It should not be grazed as short or as late into the fall as wheat. Barley does best on fertile, well-drained soils, but is also well adapted to sandy soils. Rye is the most cold tolerant and the least picky on soil and moisture requirements of the small grains. Winter oats are best adapted to well-drained clay and sandy loam soils. They do not perform as well under extremely dry or wet conditions as do wheat or rye. Fescue is one of the most commonly planted cool-season perennial grasses for livestock forage. However, a naturally occurring endophyte fungus can cause fescue toxicosis, leading to poor weight gain and reproduction in animals consuming the forage. Summer sluggishness in cattle grazing fescue pastures can be attributed to this. Therefore, to optimize livestock gains, it is recommended that you plant or reestablish pasture with endophyte-free varieties of fescue. However, this is a decision that's up to the producer. Orchard grass is one of the most productive perennial cool season grasses. It is tolerant to shade, fairly drought resistant, has a moderate winter hardiness, and matures very early in the spring. Orchard grass can produce 2.5 to 4 tons of high-quality forage per acre with good fertility and management. Its tall growth form and regrowth habit make it better suited to rotational grazing than to continuous grazing. New stands should be 10 to 12 inches tall before grazing or harvesting. Annual or perennial ryegrasses are good winter forage for cattle and wildlife. Their high palatability and digestibility makes them highly valued for dairy and sheep forage systems. They have a high yield potential, they are quickly established on site, and they are a good choice for wet soils. There are several native warm season grasses that are recommended for integration into a silvopasture system. Switchgrass, big blue stem, little blue stem, and Indian grass are the most common native warm season grasses established and incorporated into pasture management. While seed can be expensive, native warm season grasses provide cattle with more nutritional diversity in their forage. For example, big blue stem is an excellent summer forage that can produce almost 3 pounds per day on steers, while Indian grass can produce around 2.5 pounds per day. Native warm season grasses are also important if wildlife diversity is a management goal. Many wildlife species favor native warm season grasses for nutritional diversity. These grasses, switchgrass, big blue stem, little blue stem, and Indian grass, have an optimal production range from March through June. In summary, native warm season grasses also are important if your goal is to improve wildlife habitat. Since acreage in native grasslands has been greatly reduced due to pasture conversion to exotic forest species, wildlife species will be attracted to a well-managed native warm season grass system. If you have questions about the types of forages that are most appropriate for your area or property, consult with the Natural Resource Conservation Service or your local cooperative extension. Welcome to Module 5, Lecture 5B, Livestock Management, Rotational Grazing, from the web-based course Pine Silvopasture in the Southeast. High impact areas associated with traditional grazing can have detrimental impacts on tree growth and survival in a silvopasture system and lead to soil erosion. For a well-managed silvopasture, rotational grazing is recommended. Rotational grazing involves using several pastures or paddocks, with one being grazed while the others recuperate. A proper rotational grazing system is designed so that the nutritional needs of livestock can be met efficiently, forage yield and quality as well as pasture persistence can be optimized, and economic profit can be realized through improved efficiency and productivity of livestock. Traditional stocking systems involve continuously grazing animals on a single pasture throughout the entire grazing season. Rotational grazing yields higher quality pastures and favors the sustainable production of legumes and other desirable forage species. Moving to an improved grazing system will improve yield per acre beyond that of continuous grazing. Rotational grazing allows the producer to adjust stocking rates to the changing growth rates of forage throughout the season. Continuous grazing, on the other hand, does not allow for pasture rest periods that allow forage regrowth to occur. Continuous grazing can therefore lead to overgrazing during slow forage growth periods, which reduces the potential yield of the pasture. Rotational grazing systems have a number of advantages as well as some drawbacks. Rotational grazing can reduce supplemental feeding and pasture waste. It can improve forage composition and yield improves animal waste distribution. It also minimizes daily fluctuations in intake and quality feed and allocates pasture to animals more efficiently based on their nutritional needs. It is important to realize that a well-implemented rotational grazing system typically entails more management, time, and labor than continuous grazing. It also requires more fencing and water facilities and requires a good understanding of forage growth cycles and regrowth. With more cattle in smaller areas, rotational grazing can result in mud and soil compaction, so the operation must be monitored more closely. Managers can use a versatile fencing strategy to utilize pasture blocks or paddocks more efficiently to control pasture allocation. This allows animals to be rotated to new grazing areas before they graze the new regrowth of forage plants, allowing a sufficient recovery period for forages. Paddocks should be laid out as squarely as possible and on similar soil types. Square paddocks require less fencing to enclose a given area and reduce distances to water. Square paddocks also generally result in more even manure distribution than paddocks of other shapes. However, adjustments must be made for the soil productivity and the lay of the land. A rule of thumb to follow is that rectangular paddocks should not be more than 4 times as long as they are wide. There are many paddock design options for rotational grazing. A producer new to intensive rotational grazing may want to start with just 4 or 5 paddocks and then move up to 8 or 10. Watering structures can be arranged to best facilitate access for livestock. There really is no blueprint or single model to follow in setting up a grazing system. It's best to start at a level you're most comfortable with. If you have streams that run through your property and pasture units, landowners can receive cost share funds to fence stream areas from livestock grazing. In many areas, this is a very economical alternative use for the protection of water quality. However, streams on properties can be integrated into smaller paddocks for short duration grazing while still protecting the stream and water quality. The location of gates in a rotational system is very important to help facilitate the movement of livestock from one paddock to another. You will also need to take into consideration the placement and alignment of temporary lanes and alleyways to move cattle easily where you need them to be. Temporary lanes can be easily established using polywire or polytape, which can be moved throughout your pasture system. The picture in this slide is an example of a landowner's rotational grazing design. You can experiment with different plans and designs using aerial property photos. For most typical beef cattle operations in the southeast, 5 to 10 paddocks may be sufficient. This allows paddocks to be grazed for 3 to 7 days and then rested for a month. Aerial photographs are available at the local Farm Service Agency office. A well-designed planning map should be a basic grazing system with water in each field. It should be divided based on productivity and have enough fields to begin rotational grazing. In summary, a rotational grazing system with paddocks gives the manager greater control. Designing a pasture system involves many decisions, including the number and size of paddocks, the location of water sources, and lane placement and livestock flow. However, the most important factor in developing a rotational grazing system is to develop one that's right for the landowner, the farm's resources, and the land's capabilities. Welcome to Module 5, Lecture 5A, Livestock Management, Fencing and Watering, from the web-based course, Pine Silvopasture in the Southeast. Proper fencing is a necessary component to reduce overgrazing in an efficient rotational grazing system. We'll cover rotational grazing in more detail in Lecture 5B. Fencing plans need to follow NRCS specifications, extension publications, or guides published by reputable fencing companies for requirements to meet local environmental conditions and special livestock considerations. High tensile wire is recommended when using energized fences for border areas and is also used for cross fencing. Larger diameter wires create less resistance and therefore better current flow. Therefore, it is recommended to use at least one 12.5-inch gauge double insulated cable as your lead out to reduce resistance. The number of strands depends on the type of livestock being grazed. Generally, a minimum of 4 to 6 strands is recommended for border fencing, and 1 to 3 strands is recommended for cross-fencing cattle. However, the number of strands and strand arrangement may be different for other livestock such as sheep or goats. Energized fences can be easily installed and provide a psychological deterrent when the fence carries a proper current. AC powered units are the best choice for energizing a fence if 220 or 110 volt power is available. Solar recharging battery systems can also be used and installed easily on site. A properly installed energizer should produce 1 joule per mile of fence. To assure effective operation, the energized fence needs to be properly grounded with a minimum of 3 feet of ground rod per joule output. This is typically provided by 3 96-inch ground rods or other configurations in shallow soils placed at least 10 feet apart. They should also be protected from lightning by installing a surge protector at the power source, a lightning choke at the fence, and an additional ground rod every 3,000 feet of fence. Polywire or polytape is another tool, another fencing type that can be used for temporary or portable cross fencing to create smaller paddocks for intensive grazing or to allocate stockpiled pastures for winter grazing. Electrified polytape is very visible and easy to use for dividing a pasture. Polytape actually flutters in the wind, making it more visible and serving as a deterrent to livestock as well. Polywire and polytape fences are also easy to move. Paddocks can be easily established with energized polywire fencing and moved as needed when cattle are accustomed to the fencing. This enhances the manager's ability to more easily create grazing areas, move cattle from paddock to paddock, and provide optimum forage recovery periods. There are also a few simple tools that are extremely useful when using energized fencing as part of the grazing system. The tool known as a spinner. Before installing high tensile wire, acquire a spinner to reel out the wire without adding twists, which is a frustrating chore for anyone who's had to get rid of kinks or twists while trying to set up a fence. Inline switches are also wise investments to locate faults in fenced areas. By strategically locating switches, a landowner can save miles of walking when tracing electrical current using a voltmeter. Bungee gates are also easy to set up and make moving between paddocks much easier. Animals acquire water through drinking and from the moisture in the forage that they eat. As air temperature increases, water requirements also increase. This becomes especially critical as air temperatures exceed 77 degrees Fahrenheit. The need for available drinking water is compounded because forages become drier at higher temperatures. At 90 degrees Fahrenheit, a 600-pound growing steer needs about 13 gallons of water per day. At 60 degrees, that need falls to around 8 gallons per day. One distinct advantage of a silvopasture system is that shade is distributed throughout the pasture and greatly reduces high temperature stress on livestock. A water source should be available within 600 to 800 feet of cattle, but avoid placing portable water tanks in the center of a paddock system. When forage resources are far from water supply, cattle move back and forth to the water as a herd. This limits the number of times per day the animals water and the total consumption of both water and forage. And a centrally located water source can result in compaction and erosion immediately surrounding the watering site. Consider using portable water tanks that can be moved easily between paddocks. If installing permanent tanks, consider concrete tanks and tank covers. Heavy equipment tires are also a popular and durable choice. Cleaning the inside of tanks may be necessary to remove calcium residues, algae, and other junk. Water supply options for silvopasture also can include wells, creeks, ponds, spring developments, and even municipal or rural water systems. Ponds can also provide a good reliable source of drinking water for livestock and wildlife, as well as providing other benefits. The pond's watershed should be protected from erosion and excess agricultural chemical or nutrient runoff so it can provide good clean water. This is not a problem in a well-managed silvopasture system. When water is close to forage, the herd's social structure keeps animals watering more frequently as individuals. This keeps the herd dispersed throughout the paddock and results in a greater portion of time spent grazing. Traveling long distances to water tends to promote overgrazing in areas closest to water and underutilization of forages which are located at greater distances from the water source. Overgrazing causes excessive compaction of the soil and has negative impacts on forage and tree production in a silvopasture system. In summary, over the years there have been many advances in livestock watering systems design and fencing materials that have made rotational grazing both convenient and more affordable. However, there are some special considerations that must be given to water and fencing in a silvopasture system to maintain productive pastures and to optimize livestock health. Welcome to Module 4, Lecture 4B, Canopy Management and Thinning, from the web-based course, Pine Silvopasture in the Southeast. Canopy management is an essential element of maintaining a productive silvopasture. While cool season grasses can thrive at higher canopy densities, i.e. more shade, warm season grasses require more sunlight. Even forage in silvopasture alleys can be affected by shade produced from the tree rows. Therefore, pruning and thinning play an important role in the production of high-quality forage. As the trees planted in a silvopasture system begin to grow, their canopies produce more shade. While pruning trees helps to open up the canopy, thinning is also necessary to maintain forage production and develop higher quality timber. A 25% to 60% canopy is needed to sustain warm to cool season grasses. While some forage species will thrive in full sunlight, studies have shown that shade can actually increase the quality of many forages. A spherical densiometer is a tool used to measure and calculate canopy density, which is more accurate than eyeballing a site. The instrument has a convex mirror with intersecting lines that form a 24-point grid. Because the mirror is convex, it reflects the canopy overhead. To use a densiometer, hold it level in front of the body. You can count and record the number of grid squares that are more than 3/4 filled and divide this number by 24, which is the total number of grid squares, to calculate the percent coverage. Or you can multiply the number of empty squares, those less than 1/4 filled, by 4.17 and subtract this number from 100 to give you the percentage of canopy cover. Multiple readings taken through random places throughout the stand can be averaged to get a canopy density percentage for the site or the particular plots you are estimating. Planting arrangement plus tree growth dictates the thinning schedule. When canopy closure begins to reach 50% per your densiometer readings, a thinning should be considered. Pines on good sites can typically be thinned when they reach 12 to 15 years. However, this depends on a number of factors: how the silvopasture was initially established, or if it was converted from an existing plantation, among other things. If trees were planted initially at 150 to 200 trees per acre, only one thinning may be necessary well into the rotation, perhaps at the 20-year mark, to remove poles or saw or veneer quality logs and provide additional space for 10 more years of growth for the high-quality saw logs that are left. Thinning may be needed every 5 to 7 years to remove the canopy, improve tree quality, and sustain forage production. If you are planning on converting an existing forest or pine plantation to a silvopasture, trees may be thinned to an optimal density for forage production. Trees should be selected and removed to open the canopy to at least 30 to 35% to establish forage. If the stand is under-thinned during this conversion, it may require an additional thinning within 5 years to sustain forages that may get shaded out as the canopy begins to close again. After any major pruning or thinning operation, large amounts of slash and debris may build up. A prescribed burn after a thinning is an efficient way to clean up debris and also to remove any competition or undesirable weed species that may have established themselves on the site. Forage alleys, especially in silvopasture systems that were originally established in open pastures, will eventually serve as the access roads for thinning and harvesting, which reduces the need for additional clearing and road construction for logging operations. In summary, canopy management is critical for successful forage growth in a silvopasture. Well-executed pruning and thinning will create high-quality trees for timber as well as high-quality forage for livestock. Having the proper equipment for these tasks is imperative. If you have questions, you may contact your county or district forestry office or a private forestry consultant for recommendations on pre-commercial thinning and marketing your timber.